So I think I will not again spend much time discussing these optional components simply because we have gone and discussed them quite in detail. We said that source coding is sometimes considered part of formatting or digitization stage, in which case when we introduce the complexing bit or the compression of the digital bits, that is when we call it source coding. And when we don't do that, it is purely called formatting or digitization. And we say the purpose of that is to make sure that we reduce some bits or some unnecessary redundant bits and therefore save on bandwidth. And we see now that some of the examples of source coding are given here below, like predictive coding, block coding, variable length coding, among others. So we will not necessarily go into depth on this, but at least we are sure to mention what source coding entails. We said that source coding removes redundant or unneeded information. Our next our next block to discuss very briefly is the encryption. And we say that encryption is used to provide some privacy. It prevents unauthorized or unauthorized users from understanding messages or injecting some false messages into the system. And most importantly is to make sure that only people who are intended to receive the message. And establishing authentication means preventing unauthorized persons from injecting some spurious signals, the concept we refer to as spoofing, into the channel. And I think that is quite clear, and we have measured it before, and therefore I will not really discuss more about that. Now we discuss channel coding, and we say that channel coding uh, is used for the systems that uh, are likely to experience error or noise. And therefore, what we do is that we say that a sequence of message symbols becomes transformed to a sequence of channel symbols, where each channel symbol is denoted as UI. And we say that those channel symbols have a reduced or an increased redundancy. We say actually it's more or less reverse, not necessarily reverse. I think I should not use that word. It's opposite or addition of redundancy. There are many ways you can implement channel coding, but one of them is introducing redundant bits, which allow the system to withstand the rise of errors that might be introduced by the channel or losses, and therefore when the bits or the digital symbols are received on the other side, it's much easier to recognize that some bits might be in error and even correct them. So that is the most important thing, and I think I have said that before. And we can say now that there are two forms or broad categories that we can perform channel coding, and one of them is waveform coding, which produces new waveforms with better performance. An example of that is MRA signaling, and we're going to be discussing that at a later stage. And then there are more advanced versions of of channel coding, like antipodal, orthogonal, trellis-coded modulations, among others. The second category is the one that we refer to as the structured sequences, which involves the use of redundant bits to determine the occurrence of error. And the examples of that are block coding, convolutional coding, and table coding. At an advanced level, you are going to discuss discussing this concept, but for the undergraduate, it suffices to just mention those concepts by name. And we talked about briefly about multiplexing and multiple access. And we said that multiplexing happens locally, whereas the multiple access happens remotely. And we said that the similarity between these two is that both of them provide bundling of signals or sources. So the idea is that we are bringing many signals or many sources together, and they are sent as one uh, uh, as one bundle. And we also say that the difference is that the multiplexing might happen in a circuit board, or like say, I normally give the example of a radio. Let's just give a radio. Radio is receiving multiple signals at the same time, and it has a knob that you rotate, and when you rotate, it selects one of them. So that kind of ability to have to receive multiple signals, but you are only tuning to the one that you require is the concept that we can use to demonstrate that of multiplexing. Whereas the multiple access, we are saying that a channel is transmitting many sources or many signals, but then each of the signals is able to stay on its own channel without interfering with this other one. So they are traveling on the same, probably they are sharing the frequency, they might be sharing the time, or it might be even coded multiple access. So when they share the medium, but they have different. Each of them is transmitting on its own kind of space. Then we say that is multiple access. So we now jump to we are discussing the non-essential blocks or the optional blocks that are part of DCS, and we now say that frequency spreading is one of them, and we say that it can produce a signal that is relatively invulnerable to interference or attack. We talk about an outsider interfering with your signal, and therefore we say that we normally introduce the concept of frequency spreading, which we are going to be discussing at a later stage. And there are a number of them. There is a direct sequence spread spectrum, there is a frequency hopping spread spectrum, and there is a time hopping spread spectrum. So there are many others, but the idea is to make the signal withstand interference or attack by an outsider. The last of them is synchronization. Amongst the very key elements, we see that all the signals, for them to be retrieved or for them to be carried by the carrier, they require to have some form of synchronization of the signal as they are generated or as they are carried by the carrier. So that idea of making sure that the clocks of the receiver matches the clock of the transmitter, that is the idea we discussed. It's called synchronization. I messed up with my references, but there is a important note that we are having here, that the blocks, the way we have ordered them, is not necessarily the must way in which they must be implemented, particularly the optional ones. And actually, the optional ones are the ones that they can be disarranged, such that in that block, I don't want to go up there. We can, at some point, we might start with multiplexing before we do channel coding, or we can start with encryption before we do multiple access, and vice versa. So we are saying that they do not have to follow the exact order that we have given up there. And finally, I have this figure that we should call figure 2, that somehow summarizes what constitutes of all the blocks that we have discussed very briefly. And I remember I mentioned that at formatting stage, we normally have sampling, quantization, and encoding. At source coding, we have mentioned a number of them, but the key point you need to remember is that when we are doing the source coding, we introduce compression. Sometimes it might be lossless or it might be lossy. And we have said that there are a number of methods in which you can achieve the source coding. Then the baseband signaling that we mentioned that is achieved as part of pulse modulation is the one that that gives you the line codes. And I remember I mentioned the likes of return to zero, Manchester coding, among others. So that is what that signal that stage constitutes. And then the equalization is a bit more technical for probably for our level. Just mentioning those ones is sufficient. Then we talked about band pass signaling. This is our what we are going to be discussing in bulk of this unit, but it is important that we differentiate between the concept of coherent and non-coherent. And we, just for the sake of introducing this concept, is that coherent signaling is the one where we have the clock requires to be synchronized for us to perform the modulation, whereas in the non-coherent, we do not require synchronization of the clocks because we achieve the demodulation in some other method. So that is a major difference that you should remember. Then talk about channel coding. We have said there are two categories of channel coding. And the key idea here is to introduce, I'm actually repeating this many times because introduce a mechanism, and one of them is redundancy. And when you have reduced the redundancy, you have made sure that even when the channel introduces some losses or errors, the bits or the digital message symbols that have been transmitted can withstand. We are still going to be able to receive the symbols despite the errors that have been received in the channel. Of course, there are some methods of synchronization that we might have beyond our scope. The multiple access and the multiplexing methods are mentioned here. Time division, multiple access, code division, multiple access, among others. So you can see that. And then we have also said we are going to be discussing this one in detail at a later chapter. And there are three of them: the direct sequence spreading, frequency hopping spreading, spread spectrum, and then time hopping spread spectrum. And lastly, there is the encryption beyond the scope of our study for this course, but it is just good that we understand where each of these fits in the big